Urantia during the early land life era, the early reptilian age. The era of exclusive marine life has ended. Land elevation, cooling crust and cooling oceans, sea restriction and consequent deepening, together with a great increase of land in northern latitudes, all conspired greatly to change the world's climate in all regions far removed from the equatorial zone. The closing epochs of the preceding era were indeed the age of frogs, but these ancestors of the land vertebrates were no longer dominant, having survived in greatly reduced numbers. Very few types outlived the rigorous trials of the preceding period of biologic tribulation. Even the spore-bearing plants were nearly extinct. The erosion deposits of this period were mostly conglomerates, shale, and sandstone. The gypsum and red layers throughout these sedimentations over both America and Europe indicate that the climate of these continents was arid. These arid districts were subjected to great erosion from the violent and periodic cloudbursts on the surrounding highlands. Few fossils are to be found in these layers, but numerous sandstone footprints of the land reptiles may be observed. In many regions, the 1,000 feet of red sandstone deposit of this period contains no fossils. The life of land animals was continuous only in certain parts of Africa. These deposits vary in thickness from 3,000 to 10,000 feet, even being 18,000 on the Pacific coast. Lava was later forced in between many of these layers. The Palisades of the Hudson River were formed by the extrusion of basalt lava between these Triassic strata. Volcanic action was extensive in different parts of the world. Over Europe, especially Germany and Russia, may be found deposits of this period. In England, the New Red Sandstone belongs to this epoch. Limestone was laid down in the Southern Alps as the result of a sea invasion, and may now be seen as the peculiar dolomite limestone walls, peaks, and pillars of those regions. This layer is to be found all over Africa and Australia. The Carrara marble comes from such modified limestone. Nothing of this period will be found in the southern regions of South America, as that part of the continent remained down and hence presents only a water or marine deposit continuous with the preceding and succeeding epochs. 150 million years ago, the early land life periods of the world's history began. Life in general did not fare well, but did better than at the strenuous and hostile close of the marine life era. As this era opens, the eastern and central parts of North America, the northern half of South America, most of Europe, and all of Asia are well above water. North America for the first time is geographically isolated, but not for long, as the Bering Strait land bridge soon again emerges, connecting the continent with Asia. Great troughs developed in North America, paralleling the Atlantic and Pacific coasts. The Great Eastern Connecticut Fault appeared, one side eventually sinking 2 miles. Many of these North American troughs were later filled with erosion deposits, as also were many of the basins of the fresh and saltwater lakes of the mountain regions. Later on, these filled land depressions were greatly elevated by lava flows which occurred underground. The petrified forests of many regions belong to this epoch. The Pacific coast, usually above water during the continental submergences, went down excepting the southern part of California and a large island which then existed in what is now the Pacific Ocean. This ancient California sea was rich in marine life and extended eastward to connect with the old sea basin of the Midwestern region. 140 million years ago, suddenly, and with only the hint of the 2 pre-reptilian ancestors that developed in Africa during the preceding epoch, the reptiles appeared in full-fledged form. They developed rapidly, soon yielding crocodiles, scaled reptiles, and eventually both sea serpents and flying reptiles. Their transition ancestors speedily disappeared. These rapidly evolving reptilian dinosaurs soon became the monarchs of this age. They were egg layers and are distinguished from all animals by their small brains, having brains weighing less than 1 pound to control bodies later weighing as much as 40 tons. But earlier reptiles were smaller, carnivorous, and walked kangaroo-like on their hind legs. They had hollow avian bones and subsequently developed only 3 toes on their hind feet, and many of their fossil footprints have been mistaken for those of giant birds. Later on, the herbivorous dinosaurs evolved. They walked on all fours, and one branch of this group developed a protective armor. Several million years later, the first mammals appeared. They were non-placental and proved a speedy failure. None survived. This was an experimental effort to improve mammalian types, but it did not succeed on Urantia. The marine life of this period was meager but improved rapidly with the new invasion of the sea, which again produced extensive coastlines of shallow waters. Since there was more shallow water around Europe and Asia, the richest fossil beds are to be found about these continents. Today, if you would study the life of this age, examine the Himalayan, Siberian and Mediterranean regions, as well as India and the islands of the southern Pacific basin. A prominent feature of the marine life was the presence of hosts of the beautiful ammonites, whose fossil remains are found all over the world. 130 million years ago, the seas had changed very little. Siberia and North America were connected by the Bering Strait land bridge. A rich and unique marine life appeared on the Californian Pacific coast, where over 1,000 species of ammonites developed from the higher types of cephalopods. The life changes of this period were indeed revolutionary, notwithstanding that they were transitional and gradual. This period extended over 25 million years and is known as the Triassic.